Okay, problem number one. The number of students in each group if 36 students are split into 4 equal groups. Okay, so we're looking for keywords. Our keywords here are split into. If we're splitting things into, that's going to be a keyword telling us that we are dividing. So we're going to look for 36 divided by 4. So 36 times 4, no. 4 divided by 36, no. 4 minus 36, no. 36 divided by 4. There we go. 2. The number of minutes in any number of hours. Okay, so the number of minutes in any number of hours. Well, we know that there are 60 minutes in an hour. What we don't know is how many hours there are, so that's going to be the variable. Looks like we're using x here. So we have 60 minutes and per hour. So when we're looking for that, that's going to be multiplication. So let's look for the one that shows 60 times x. We have 60 divided by 6, no. 60 times x, yep, that looks good. Let's check the others. 60 plus x, no. X minus 60, no. So looks like B is our best choice. Okay, number 3. It says, write 3 phrases that the following expression could represent. Okay, so now we're going to be looking and using our keywords to show what this expression is. So we have x minus 4. Well, we could simply write that. We could write x, the word minus, and 4. We've also learned the word difference. So let's go ahead and put that in. Now when we use that, we go ahead and say the difference of, and then we list them in the order that they come. So we'll list it with x and 4. So we're going to say the difference, you guys would write that out, of x and 4. Okay? And now we have one more that we need to come up with. So we use minus, we use difference. Let's use less than this time. Less than's the tricky one because less than tells you that you're going to have to use subtraction, but then you're going to have to flip it. So instead of it being the difference of x and 4, or I'm sorry, instead of it being x less than 4, it's going to be the opposite. You're going to flip it, so you're going to put 4 less than x. So we'll write 4 less than x. Okay, so there's 3 different phrases. Again, we could keep going. There are a couple more we could do, but those 3 will do. Number 4, use order of operations to find the value of each expression. So what this is going to refer back to our order of operations, which is PEMDAS. The important thing that we learned this year is that she wants us to write it vertically in writing the multiplication and division and addition and subtraction. And then we add the line. So this one shows parentheses. This is going to be our exponents. This is multiply and divide, whichever comes first from left to right. And then this is your add or subtract, again, whichever comes first from left to right. Okay, so problem number 4 says 32 divided by 4 times 2. Okay, so we have division and multiplication, so that means we're going to do whichever comes first from left to right. So in this case, we have division first. So we're going to do 32 divided by 4. 32 divided by 4 is 8. Okay, bring down the rest. Now we have 8 times 2. 8 times 2 is 16. There's our answer. Okay, number 5. It looks nasty, but it's not too bad. Just break it down one step at a time. So we start off with P. Do we have any parentheses? Yeah, we actually have 2 sets of it. We have our outermost bracket, and then we have our inner parenthesis. So we're going to start off with the innermost parenthesis first. I see an addition sign, and I see a multiplication sign. So with our PEMDAS, we start off, multiplication comes before addition and subtraction. So we're going to go ahead and start off with the multiplication. So let's do that. 3 times 4 is 12. We're going to bring down all of the rest of it. 15 plus 12. And then we're going to close it. Okay, again, I'm going to stick with my parenthesis here. Got to finish off the innermost parenthesis first. So, 3, bracket, 15 plus 2. 15 plus 2 is 27. Okay, oops. 27. Okay. All right, now I can't do anything more with this, so that's good. But I can, let's move this up. Okay, I can go ahead and simplify my 3 squared. Okay, 3 squared, if I simplify that, that becomes 3 squared. That does not mean 3 times 2, that means 3 times 3. So 3 squared is 9. Okay, let's bring down the rest. 27 divided by 9. Okay, so here we are. Still have my 3 on the outside of the parenthesis. Then on the inside of the parenthesis, I have 27 divided by 9. So this is the part I'm going to go ahead and simplify first, because again, parenthesis comes before multiplication. So 27 divided by 9 is 3. Okay, bring down the 3. Now I can finally multiply that 3 on the outside with what's inside the parenthesis. And 3 times 3 is 9. There's my final answer for number 4. Alright, number 6. Now we have an algebraic expression, and it says to evaluate the expression if x equals 7, y equals 4, and z equals 6. So simply we're going to go ahead and take what we know, and we're just going to plug them in. So we're going to take out the x, and we're going to plug in what x equals. X equals 7. So, take it out, plug it in. Okay, so plus, parentheses, 30 minus 3. Now in this case, I'm going to take out the z, and in parentheses, I'm going to put what z equals. In z, it says equals 6. So let's plug in the 6. Okay. And I'm going to close the final parenthesis up there. Okay, so inside the parenthesis, I have 30 minus 3 times 6. So I have subtraction and I have multiplication. Again, with PEMDAS, I do it in the order that it comes. So I have the subtraction down here, and then I have the multiplication up here. So we're going to multiply first. So let's go ahead and write down 7 plus 30 minus 3 times 6. 3 times 6 is 18. Okay. Again, order of operations, I have plus, and then I have some parentheses here. So I need to take care of my parentheses. Okay, so 30 minus 18. So 30 minus 18 is 12. Bring down the rest, 7 plus 12. Okay, now we can go ahead and do that. 7 plus 12 finally is 19. And there's your answer. All right, number 7. Moving down here, it says, name the property shown by the statement. Okay, whenever I look at these, I don't try to just look right away and see, oh, they're moving the parentheses around. Oh, it must be associative. What I do is I like to read the numbers. I want to make sure that I read the numbers and that the numbers are in the same order. So, if I know they're in the same order, then it can't be commutative. Okay, so 31, 4, 17. 31, 4, 17. So they didn't move around, they didn't commute, so it can't be the commutative property. So now let's see if they regroup the numbers. If they regroup the numbers, then that would be the associative property. So here they have 4 and 17 together. Over here they changed it. It's not 4 and 17 anymore. Now it's 31 and 4. So they changed who they associated with. So that means it's the associative property of, and in this case it's of addition. Okay? Okay, next part here, number 8 says, show an example of each identity property. Okay, first one is the multiplicative identity. So with the identities, I always like to think, I want to go in with a number and I want to come out with that same number. So with multiplication, what can I multiply 8 by? Oops, let's use the right side. What can I multiply 8 by and still come out with an 8? Okay, well with multiplication, if I multiplied it by 0, that would come out as 0. So I don't want to do that. But I do know if I multiplied 8 times 1, I still could get 8. So that is the multiplicative identity. It's just whenever I multiply something by 1, I get that same number. So we could also write 5 times 1 equals 5, or we could get fancy and say n times 1 equals n. Okay, that shows the multiplicative identity. So the additive identity is real similar in that we say, okay, well, if I start off with 8, what could I add to 8 and still walk out with that number 8? So I could add, if I added 1 to 8, I wouldn't get 8 anymore. I would get 9. So I can add 0 to 8 and still get 8. So that's the additive identity. It says if I add 0 to any number or variable, I'm still going to get that same number or variable I started with. So I could show it with letters by going n plus 0 equals n. Or again, I could use another number like 4. 4 plus 0 equals 4. So that'd be the additive identity. Okay, we have word problems down here. Let's look at these two. Solve each problem. On an average workday, 150 cars go through a toll booth per hour. Okay, so that looks important. So 150 cars per hour. The driver of each car pays 50-cent toll. How much money is collected in 8 hours? Okay, so let's see here. So we know that 150 cars go through per hour. Each car pays 50-cent toll. Okay, so we're going to set this up. 150 cars, 150 times the hours. And then we also know that for every car, they also charge 50 cents. Okay, so this would be our expression if we didn't know anything as far as how many hours. But in this problem, they did tell us how many hours. So we're going to take out the h, and we're going to plug in. We're going to plug in an 8 there. So let's go ahead and change that to 0.5 times 150. And instead of h, we're going to change that to 8. So we'll multiply it in order. And you have 50 times 150. You get 75 times 8. 75 times 8 would be, what is that, 600? So that would be $600 in 8 hours. that in a sentence. Okay, so problem number 11. It says Jackie starts work at 9:30 a.m. Okay, so she starts work at 9:30 a.m. In the morning, she reads the newspaper for 17 minutes, showers and gets dressed for 30 minutes, and rides her bike to work in 14 minutes. Okay, what is the latest she can wake up and still be on time for work? Okay, so what we have to do is we kind of have to work backwards. We're going to take our time here, and we're going to find out how much they add up to together. So we're going to go 30 plus 17 plus 14, and we'll see how much time that comes up to. So 4 plus 7, that's 11. Carry the 1. 1, 4, 5, 6. So that's 61 minutes there. Okay, we're going to take that and we're going to subtract that from the 9:30. So 61, if I was at 60, that would be 1 hour. So 1 hour less from 9:30. So minus 1 hour would be 8:30. Okay, I do need to take into account that one more minute. So minus 1 minute will be 8:29. So what is the latest she can wake up and still be on time for work? The latest she can wake up and still be on time for work, again, you'd write that in a sentence, would be 8:29 a.m. Okay, for number 12 here, it says complete the table of values. Suppose you read 20 pages of a novel per hour. So that's going to equal 20 times the number of hours. So we're going to go ahead and take our hours and multiply each of these times the 20, and that will give us our pages read. So for the first one, we'll do 20 times the 2. 20 times 2 is 40. Okay, the next one, we're just going to keep plugging in. 20 times 3, and 20 times 3 is 60. Next one, 20 times 5, that gets you 100. And final, 20 times 6, and that gets you 120. Okay. Next one, state the domain and range. My easy way of remembering this is above, if you write the abbreviation for doctor, that will give you the easy way to remember domain and range. So, above the column with the D, all of these numbers are going to be your domain. Above the R, all of these numbers are going to be your range. So, our domain, and remember, we do have to put it with that little weird squiggly. Let's see if I can do it correctly. There we go. So, I put them in numerical order from least to greatest. In this case, they're already set up that way. So, I'm going to go ahead and write 2, 3, 5, 6. Then I got to do that little squiggly deal again. That one wasn't as good. Okay, now for the range, again, I'm just going to go to this category and list them in order again. So that's going to be 40, 60, 100, and 120. All right, that takes care of that part. All right, number 14, it says use the information in the table below to answer the next two questions. All right, we know that adult tickets cost $22, children cost $15, and seniors cost $14. Write an expression to find the total cost of admission for 6 adults, 4 children, and 2 seniors. Okay, so we know 6 adults, so 6 times an adult is 22, plus 4 children, so 4 times the children, they cost 15, so 4 times 15, and plus 2 seniors. So 2 times seniors cost 14. Okay, so that takes us, that's our expression right there. That's a numerical expression that we would use to calculate the total cost. The next part actually says to find the total cost. Okay, so now is when we're actually going to solve the problem. So I'm going to go ahead, multiply 6 times 22. Okay, 6 times 22 is 132, plus 4 times 15, that's 60, plus 2 times 14, which is 28. Okay, since we have all addition, we're just going to take them in the order they come, from left to right. So, first part, 132 plus 60 is 192. Bring down the other part, plus 28. Add these two together, and you're going to get $220. You'd want to rewrite that as a sentence, so your sentence would say the total cost of admission would be $220. All right, number 16. We're going to use the coordinate grid and try and identify some points. So our first point we have is point N. So we see that that falls right on the y-intercept. So whenever we're writing points, remember that it goes x, comma, y. First point tells you how far you're going to go left or right, and the second point tells you how many you're going to go up or down. Okay, so our first point, point N, we don't go any left or right, do we? So we just go straight up. So no left or right, that means that our first part to that, since we didn't move any, is going to be 0. Now, the second part, we do go up, so we go up 1, 2, 3, 4. Since we went up 4, that's a positive 4. So our point for the first one for N is 0, comma 4. All right. Next one, point Y, well, that falls right here. So we count how many over. So it goes 1, 2. So it goes to the right 2. So again, put your parentheses. 2, comma, and it goes up 1. So since it went up 1, that's a positive 1. So our point is 2, comma 1. All right, moving on. Number 18. 18 says, what is the rule for the relationship shown in the table? Okay, so with these, we want to kind of plug in our x value and see if we can get the y value. So we're going to plug in the x into the equations and see what works. Okay, so we're going to plug in 1 for the x and see if that comes out with 5. Okay, so let's do that. So 1, I'm going to take out the x and plug in a 1. 1 plus 6. Let's see if that gets us the 5 that we want. So does 5 equal 1 plus 6? Well, 1 plus 6 is 7. And 7 does not equal 5. So A is not correct. Okay, let's go ahead and erase that. Okay, so B, again, same thing. Now we're going to plug in our 1 in for the x here. So 1 plus 4. And let's see, does that equal the 5? 1 plus 4 does equal 5. So far so good. So we keep moving now. So let's go ahead and erase what this work is. Don't ever just stop after 1. I always keep checking. Okay, so now we're going to plug in 3. Okay, 3 plus 4. Okay, let's see. Does that equal 11? So 3 plus 4 is 7. 7 does not equal 11. So we know that B is incorrect also. Okay, erase my work, and I'm only erasing because I don't have enough room here. All right, C. Okay, let's go. Oops, let's erase this again. Okay, C. Now I'm going to plug in 2. I'm going to take out the x and plug in the 1. 2 times 1 plus 3. Again, that's just from the equation right here. Okay, so 2 times 1 is 2 plus 3. We're going to see if that equals the y. So 2 plus 3, does that equal 5? Well, 2 plus 3 is 5, and that does equal 5. Okay, so the first part checks out. Let's keep going, see if the next part checks out. Okay, all right, so let's plug in the next part. Let's do the 3. So I'm going to take the x and see if it equals the y. Okay, so 2 times 3, and then plus the 3 here. So 2 times 3 is 6, plus 3. All right, so 6 plus 3, and we want to see if that equals the 11 from here. All right, 6 plus 3 is 9. That's not going to equal 11. All right, so we're hoping, we're banking it all on it being D. But let's prove it and see if we didn't make any silly mistakes. Okay, so D. Let's see here. So again, we're going to use the equation. 3 times the x value. Our first x value is 1. And let's plug that in. 3 times 1 plus 2. Again, straight from the equation. 3 times 1 is 3 plus 2. 3 plus 2 is 5. Does that equal the 5 that we wanted? Yes, it does. So far, so good. Okay, let's go ahead and erase this. Okay. Oops. Okay, get rid of that. Okay. Now let's plug in the 3. 3 times 3 plus 2. 3 times 3 is 9 plus 2. Let's see if we can get the 11. 9 plus 2 is 11, equals 11. Okay, good. We've just gone ahead and confirmed it. We've shown with our work being correct that D is the correct answer. You could go ahead and do the rest of these if you wanted just to prove it. However, I feel confident now that we've proven it. Okay. Number 19, which of the following equations best describes the graph? Okay, so let's see here. We can do this a couple of different ways. Let's start off. We have to pick a point, and we're going to plug the point into these equations. Okay, so I see a point that crosses the intersection. That's probably the easiest way to do. So I'm going to plug in the point 5, 15. Okay, so 5, 15 is the point we're going to plug into these equations and see which one of them works. So 5, 15. Okay, so I'm going to do 2 times, take out the x, plug in the 5, plus 1. And we're going to see if that equals our y value. We're going to see if that equals 15. Okay, 2 times 5 is 10, plus 1. 10 plus 1 is 11. Does 11 equal 15? No. So A is not correct. Okay. All right. Next one. Okay. Ooh, you didn't want to go anywhere, did you? Okay. Next one. Go. Okay. Next one is we're going to plug in the 5 for this one. So 3 times 5 minus 2. Okay, 3 times 5 is 15 minus 2, and we're going to see if that equals the 15. 15 minus 2 is 13. That is not going to equal 15. So again, that one is incorrect. Okay, let's get rid of that. Okay, next one, let's move on to C. Okay, 5x, oops. Now I'm going to take out the x because I know what x is. We're going to see if 5 times, take out the x, plug in the 5, minus 10, again from this problem. All right, and we're going to see if that equals the 15 from here. 5 times 5 is 25 minus 10. Let's see if that equals 15. 25 minus 10 is 15, so 15 does equal 15, so far so good. Now, just like the other problem, we do need to double check to see if there are other points that will confirm that that's the best choice. So we need to go ahead and look at another point here. Okay, so the point I'm going to go ahead and choose, let's choose some low numbers here. Let's go ahead and do 3, comma, looks like that's 7. Okay, that is important that we know the point. So let's use 3, comma, 7. So we're going to verify with this point right here. So we're going to plug those numbers in now to see if it matches. So, same thing we just did. 5 times 3 minus 10. And we're going to see if we can't get 7 out of that. Okay, 5 times 3 minus 10. 5 times 3 is 15. Okay, 15 minus 10. Oh, okay, 15 minus 10 is 5. That does not equal 7. Okay, so we just came into a halting point with this one. So we're going to hope that D matches out and works with these two. Okay, so we're going to double check both points here with our final equation and make sure that that is correct. Okay, so let's get rid of what we have going on here, free us up some space. Okay, and try. All right, so here we go. 4 times, our first point we used was 5, so let's use that again. So 4 times 5 minus 5, and we're going to see if that equals the 15. Okay, 4 times 5 is 20, and let's see if that equals 15. 20 minus 5 is 15. 15 does equal 15. So far, so good. Okay, so let's go ahead and get rid of that. And now we're going to plug in the 3 and the 7. Okay, so 4 times 3 minus 5, and let's see if we can get 7 out of that. 4 times 3 is 12 minus 5. 12 minus 5 does equal 7. 7 equals 7. Hot dog, we found our answer. Okay, final problem, number 20. This states that subtraction of whole numbers is commutative. Okay, what that means is that 7 minus 3, if it were commutative, that means I could move the numbers around and say 3 minus 7. Now, for that to work, both sides would have to equal each other. 7 minus 3 is 4, whereas 3 minus 7 is actually a negative 4. So, subtraction of whole numbers is not commutative, and this right here proves that.